He's in the lab?
Yes, sir.
That's great. Okay. So now it's recording, I think. Yeah. So today we start our discussion on practicing the TRIZ method. So before that, can somebody remind me what are the different steps in TRIZ method we are going to follow? Can somebody remind me? Different steps we follow in TRIZ method? Because in first year you may be thinking that you know TRIZ method because you heard about the definition. No, TRIZ method is very vast and deep. Okay, so you must practice as well as understand how to really use the technique. So let me share this. This is what I actually gave you as the system to apply the TRIZ method. Sometime I thought let us go to some electronic device. It's electrical as well as electronic, both. So because somebody may have the doubt whether we can apply on electronic devices or not, right? So this time I thought I will take in this. So let me know. So what kind of um, what is the method or what are the different steps you see in the TRIZ method? Can somebody remind me or should I repeat it? Anybody? Should I take names? Yes, PhD students. Any idea? Yes, somebody.
Yeah, first is considering the system or a problem.
Yes, considering the system or a problem is already given.
Yeah.
Yes.
Okay. Next,
Analyze it with respect to parameters.
analyze with respect to parameters. I reduced your problem. That is also given. So parameters are already given here. So these are all parameters, if you see. So these are all measurable things. Okay. So these are all parameters, one way or other way measurable. So what you need to do now
Map the
after
system
that?
parameter.
Ah,
Map the system parameters to TRIZ-based parameters.
yes, mapping the system parameters with the
TRIZ-based parameters.
TRIZ based generalized parameters. We call them as generalized parameters. So that anybody did already. So mapping with the TRIZ generalized parameters. I think if we habituate to two computers, teaching in single computer is a difficult task. Okay. So anybody already did? So these are your parameters. That is polarization. So surface charge, surface area, surface roughness, surface pattern, continuity of the surface, potential difference, force applied, frequency of force applied, that is external force, this one. Okay. Hope my PPT is visible to everyone. So number of layers of what? This one, this 2D material. So in our research, actually, we are doing with some other universities, some research we are doing. Based on that, we have taken 2D material. If you want to take some other material, I don't mind. Okay. So you can take it. So here you have a surface pattern related to 2D material, stacking that or arrangement of layers, because layers, equispaced layers, that periodicity you can measure, and continuity of the surface. Continuity of which surface? The top surface of this layer. Okay, top surface of the layer, because in electronics these are all, especially electronic fabrication, if you go in electronic fabrication you find these all things extremely important, especially continuity of the surface, arrangement, surface pattern, number of layers, surface area, thickness, polarization, whether any charge is getting accumulated there, surface roughness, and packing density of layers. So density, how layers are actually stacked here. So layers means don't get confused with electrodes. No, I am talking only about this orange color region as stacking of number of layers. It is not a single layer. Number of layers are there, 2D material layers. So 2D material, two-dimensional materials, you must have known about, you must have heard at least about the graphene, MOS2, these things. Okay. So voltage is here, potential is generated. So in general, what we do is we prepare this device. We have aluminum electrode, aluminum electrode. In between, we have 2D material of some kind. Then we are going to hit it with some object. That is, we are applying the force at some particular point with some frequency. Maybe with the periodically we are applying the force. In that particular case, we will get the voltage generated here. So that concept is called triboelectric generation. Okay. So that concept is called a triboelectric generation. That means if you apply the pulsating force or the force, this 2D materials or some materials going to generate charge over the surface. It is slightly different to that of piezoelectricity. Okay. You may remember the piezoelectricity where you apply the force or you apply the pressure, then voltage is formed. This is also same way, but here phenomena is little different. Let's not go to the deeper phenomena. Let's stick to the device. Okay. Now in this device, you have electrodes, you have different layered 2D material, and you have potential generated here, and you have applied force. And external pressure and external temperature comes under super system. In this particular case, let's not worry about these two because super system has very minimal impacts on system. Okay. In extreme conditions, you may have temperature effects and pressure effects. We may not consider that. But most of the parameters are related to this. So, your understanding of the system with respect to these parameters is most important. I am applying the force. Because of that force, something is happening in this material, which is actually generating the charge separation or the difference that is appearing as a voltage. Okay. So that is called a triboelectric device. Now these people are trying for some artificial skin, those applications by using this kind of uh, phenomena. Okay. That is about the device. I completely explained. Now you understood about the device with respect to several parameters. Okay. With respect to several parameters related to this system. So now onwards, I'm going to term it as a system rather than a device. Now, so these are all the parameters. These are the system parameters. Now, what are the related TRIZ parameters? Can somebody please? TRIZ parameters. In order to apply the or assign the TRIZ parameters, you need to understand the basic definitions of these things. Okay. So, what are the TRIZ parameters you can assign? Polarization. Polarization means what? Polarization. Any idea? Because definitely you can't tell. I don't know polarization. We're all engineering students. So what is polarization? Hmm? Why so silent? What is polarization? Then I will have yes.
It's sort of like aligning waves into a certain alignment. Is yeah.
No, that is optical polarization. I'm asking about general polarization definition. You may search in Google also. What is there? General polarization means what? You already know that. Anybody else? You can Google search also to understand the definition of that. So what is the definition of polarization? No. See, I can't see the chart now. I'm attending from single computer. Somebody can read that.
Separation, sir.
Separation of what?
Charges.
Separation of charges. So
Dipole.
in this, that's what I told. Yeah, dipole formation. That may be dipole, quadrupole, or octopole, anything. Here, what I am saying, when you apply the force, some charge separation take place. Am I right? So that is what polarization means. Separation of the charge carriers. So separation of the charge carriers means charge carriers are nothing but the substance, right? Charge carriers are nothing but electrons. So electrons are ions, whatever it may be. Those are the substance. So what you can actually assign to the polarization from the list? From the list of how many parameters? Parameter list 39. Very good. So from 39, what you can assign there? So now polarization means some kind of material is getting separated, right? Getting separated. It is not lying stable. It is just getting separated. So which parameter you can assign to that in general among those 39 parameters? You may look at the 39 parameters. So 39 parameters I already shown you in the last class. You please keep that in front of you. Yes, ma'am.
Is that weight of moving object?
It's not weight. Object is moving, no doubt about it, but still they are getting separated. So is it related to something stability?
Yeah, stability of object is there.
What is the number?
13.
13. So you can write the first parameter, stability of the object. That means if I apply the force, immediately they are going away. They are not staying stable. So it is related to stability of the object. Okay. So any other thing you can assign, you can see. Okay. Because that is what I'm saying. You have to understand it fundamentally, where you can assign some related or somewhere related parameter to that one. So charge is nothing but the material. Material is getting separated when the force is applied. It's always related to stability of the object. Next, surface charge. So I think I need not to tell the definition of surface charge. Charge means charge is a charge, nothing but electrons or ions. Okay. Even though it is electrons or ions, it's anyway material. So surface charge means what you can assign? One parameter. You just have a look at 39 parameters or features, then see anything can be generalized for surface charge. Surface charge means it's an amount. Am I right?
Should it be quantity of substance?
Quantity of substance. Very good. That's a quantity of substance because it is a substance. We are telling how much amount. So it's a quantity of substance. So what is the second generalized parameter? Quantity of substance. Here again we proved that we need to understand at a fundamental level, then we can generalize it. Okay. So what is the number? Quantity of the substance?
26.
36.
Sir, 26.
Sorry.
26.
Yes. Quantity of substance. 26. Yes, you put the number also for later. We can use that. Next, surface area. It's a direct one. So because it's the area, it's a dimension. So which parameter will come?
Area of non-moving object.
Area of non-moving object. Why non-moving object?
Because it's not in motion.
Yes, yes. Because device is not in motion, or the that 2D material is not in motion. It's the area of non-moving or stationary object. What is the number?
6.
6. Please write there. Next is little tricky. Surface roughness. Is it a area? No. So surface roughness means how you explain to a person who doesn't know about doesn't know anything about science. Surface roughness. Is it a material? Of course, it is a feature of material, but not material. Is it a area? No, it's a feature of area, but not area. That's a tricky part. How you explain surface roughness to a layman?
Sir, would it come under shape?
Yes,
Can it come under shape of the...
that's fine. If it is the shape, then how you justify that? That you tell. Don't go just like a what you say that. Guesswork don't do. Fundamentally, you understand that, then assign something. Surface roughness. How you explain to a layman? That means completely person who doesn't know anything about science.
So we could talk about it as in the terms of texture, right?
Yes, texture. How you explain?
Depending on how the surface texture is, the roughness also changes. So, like for example, more like sort of spiky like texture will have a higher sense of roughness, surface roughness, right? So things like that. It's a component of that. Can we say?
No, layman, will you explain like that? If somebody who doesn't know anything about the subject, will you explain like that?
We can also say like, yeah, if the surface is smooth, the roughness is low, like that.
Surface is smooth means what you are actually seeing and saying it as smooth.
So can we take it based on loss of energy?
No. What about the energy? It's
It
material related.
it
There is
looks
no,
yeah.
there is no shape at a
See,
micro
you
level.
are actually assigning energy to the material. No, it's not. There is no.
Shape at smaller dimensions, like smaller sizes.
Okay. Then
That means it is less rough.
how
It's smooth.
material continuity? Just below that something is there. Continuity of the surface.
Like closely arranged or periodic or non-periodic.
Continuity of the surface is a periodic or a random. Somebody said spiky. Spiky means what? Is the material continuously distributed? When you say something is rough, is the material distribution is continuous or spiky?
We can say like the imperfections on the surface. Is that so?
That's what you need to tell. Imperfection. So material is actually not distributed continuously. Okay, now you see imperfection. If you tell, definitely now you know. Okay, so then what you can assign among these 39? So imperfection of the surface, definitely it related to material, but it is imperfection related to what?
Manufacturing precision.
You search in material itself. Now you look at the shape. So whether only shape is some way or other way related to this understanding, or anything else you can assign. Because somebody said randomly it's a shape. I'll agree with that. But what is your understanding? After churning something, you said, oh, yeah, okay, surface is imperfect. That means material distributed. The distributed shape is not perfect. So somewhere other way, you have to relate it to shape only. Okay. So now you keep the shape. What is the number? Shape?
Sir, I have one doubt.
Yes, please.
In that one more option called brightness is also there. Like the smooth finishy things will give more brightness
No,
than this random.
that is the effect. What you
Okay.
are saying, if the light incident on it, it will become bright.
It's
What
like
if light won't incident?
in the one of the parameter, right? Like
No,
how
no, no, no.
surface.
See, you are in the dark, there is no light. Okay.
Okay.
How you define roughness? Because you are all optics people, you say that, okay, I will just shine the light and say whether it is rough or not. That's fine. But you are in the dark room, completely dark, no light is there. Then
Okay,
how
sir.
you are going to define the roughness? So fundamentally, roughness is defined only through material imperfection or
Okay, sir.
material continuity. For that, what is the assignable parameter in our TRIZ feature? Only shape. Is there anything else? Have a look at it. You can suggest something else also, no issue. But you have to justify that. That's why parameter, if you don't understand fundamentally, you cannot assign the generalized parameter. Because first year TRIZ method, you must have seen just a very superficial definition. Yes. So what is the
Sir,
number? Shape number?
12.
Shape number is 12. Okay. So that can be assigned. 12 is assigned to surface roughness. Okay. Surface roughness is the shape. Now you tell me surface pattern. What is surface pattern? Is it anything different from surface roughness?
it's a repetitive texture, right? It's something that can be distributed.
Mm.
So it has uniform distribution across the surface.
Correct. So what kind of parameter you will assign? Is it the same or anything else?
It would also be shape.
Yeah, it will also be shape again. Right. Next one is also continuity of the surface. Continuity of the surface is also shape. Okay. So that is the thing. Next one more challenging thing came.
So what exactly is continuity of the surface?
Continuity of the surface is how material continuity. Now you are close your eyes. Who is talking there? I am
Yes,
unable
sir.
to.
Yeah.
Yeah. You just close your eyes. Okay. Then touch the paper as well as the table in front of you. Okay. Just rub on it, slightly rub on it, the table as well as the paper. What you are actually feeling is the roughness. Okay. What you are actually feeling is material discontinuity. Okay. That is continuity of the surface.
Okay, sir. Got it.
Did you do that?
Yeah.
Okay.
The different feeling after you pass over the.
True. True.
Yeah.
Because unless you understand all parameters of any system at a fundamental level, TRIZ is not that easy. Okay, that is the beauty of TRIZ. That is why everywhere they are able to apply, including management. Okay, now, so next challenging parameter is potential difference. So for this, I think you have to Google. I think we have sufficient number of electronics people also. This is only the 8th class definition. What is the 8th class definition of potential difference? Definition of potential difference. You have some hint there itself.
Sir, it's the difference between the charges between 2 points.
Now, what is happening to charge?
It's,
They
so
are
like we can say
moving from high potential to low potential.
They are moving or they are moved.
They are forced to move.
So what is fundamentally potential means?
The force applied to the charge.
What is EMF?
Electromotive force.
Electromotive force.
Yeah.
So potential difference more or less it's an force related thing. Force on charged particle. That's it. Not so if you keep your finger in plug, you will also feel that actually. Because electrons it will force to take from your body. So it is fundamentally the force. Okay, that's why some equation also we find some delta F or something for V. How we define that? Anybody remember that electromagnetics? How we define potential, surface potential in terms of force? Delta F or minus delta F? So okay, I don't go to that. So let us understand. Already we know one name, electromotive force. That is, the charge carriers are being forced to travel from one point to another point. Then we will say there is a potential difference between 2 points. So fundamentally, it is a force. So what is the parameter assignable to this? Why this much time?
Force.
Yeah, force is already there. What is the number?
10.
10. So that is the next thing. So force applied anyway, it's a force. That's already over. Frequency of force. Now it is not a force. Frequency. Now you check. Frequency means what? What is the fundamental definition of frequency? Definition means what you understood mean by frequency.
Number of operations performed in 1 second.
Yes, number of operations per
Second.
second. Okay, number of operations per second. So number of cycles per second, number of iterations per second, like that. You will define frequency. So number of force applications per second, like that we can understand. So which parameter you will apply here?
Maybe power.
Power.
No.
Productivity.
Productivity. No. See, fundamental definition I already told you. It's a repeated action. Am I right? So because it is again and again and again it is doing, applying the force. So what is the generalized parameter you can apply?
Sir, can it be energy spent by
Sorry,
moving object?
energy spent by
Non-moving object.
non-moving object.
In our case, it wasn't moving.
No, you always correlate with the fundamental definition. If it is at least some way, if you can match. You just look at 15 and 16.
It's durability.
Hmm.
15 and 16.
It's a durability or duration.
Can I say speed?
Sorry?
Speed.
Yes, definitely.
Because speed, speed with which we apply force will also change the frequency, right?
Exact. Speed means what is the definition? Velocity per, sorry, I'm sorry.
Distance,
Distance per
unit time.
unit time. Here, number cycles per unit time. Force applications per unit time. So it is nothing but a force velocity. Am I right?
Yes.
So it is a frequency means what? It's a force velocity. So number of forces per unit time. Okay. So at fundamental level, you have to correlate. That's what I was saying. That per second is most important. So now, what is the parameter number?
9.
9. So you apply that. 9 is the speed of the object. Somebody was saying energy. How you could correlate energy? Is it energy giving or energy taking?
Sir, it would take energy if forces applied on it.
Yeah, system will take energy. Am I right?
Yeah.
But that way, how frequency is related? That you can just explain, because you must came with that E is equal to h nu, which is the electromagnetic
Yes.
energy.
Yes.
Am I right?
Yeah.
But the force which we are telling frequency is the mechanical.
Okay.
Am I right?
Yeah. Correct.
So that time, how this mechanical frequency is related to energy, that you have to explain. Then we will accept that parameter also.
Work done per unit time.
Work done per
Unit time.
unit time. What it is?
Energy.
What kind of energy? Is it loss of energy or gain of energy?
It's energy consumed to, like, energy applied to that device.
Device. That is true. Is it a loss to energy or gain to energy? What kind of energy it is? Is it kinetic energy or potential energy? That's what I'm asking.
It's potential.
Potential energy. Good. Hmm. So that way you can correlate with another parameter also if you want. So one is speed, second is the energy. But this energy you must remember, energy gained by the object. Okay?
Yes, sir.
Hmm. Not loss. Hmm. So what is the number? Other parameter number? Nineteen 20, if you see use of energy, sometimes they call it as a gain. Okay, use of energy by stationary object. I think 20. that also you can keep in the same shell. Okay, so that is the way you have to generalize parameters. So number of layers again related to what?
Quantity of substance.
Number of layers, quantity of substance is a overall quantity. Number of layers, are you going to look at okay, I think that is fine. Quantity of substance you can give. What is the number?
26.
26. Yeah. Next, layer arrangement. Generally, arrangement means what you say it as?
Sir, I had a question. Like,
Yes.
wouldn't number of layers also translate to the strength of the?
Yes.
Uh,
Yes. Strength means number of layers always related to density, because number of layers we are saying, but number of layers per unit area, it's not like that. So suppose if you
Oh.
consider number of layers per unit volume or number of layers per unit thickness, unit length, then that related to strength all the time. Okay, that's
Okay.
why you just see another one, packing density of layers. So packing density of layers is there, na? This one. The packing density of layers related to what? Strength.
That would be strength.
Yeah, that is 14. Okay. Now layer arrangement, how you say? What do you think? Layer arrangement means it's a kind of a what kind of generalized parameter you can assign? You are arranging it layer by layer. That's it. You are not mentioning any length, thickness, or anything. Nothing you are mentioning. Layer arrangement means, so material is being arranged in a particular fashion. I'm not saying random, regular, or something. It's a any idea? Any guess?
Stability of objects composition.
No.
It all like
Which one? Stability of the object.
composition because
Number?
it's 13.
No, that is not
Device
stability, right?
complexity.
It's a kind of arrangement. See, roughness case, what you did? Material is actually arranging in a particular fashion. Am I right? Pattern
Yes.
or arrangement. So,
Device
layer
complexity.
arrangement also nothing but a material arrangement, right? But in other direction.
Yes.
Yeah. So, in that case, layer arrangement also should be correlated to
So device complexity.
Device complexity.
I'm not talking about the overall device. I'm talking about that 2D material. Am I right? That's why I
Sir, it
told
should be shape.
don't consider these electrodes as layers. Okay. Only I'm talking about orange region. So in that case, my choice is shape. Okay. If you say it is device complexity, then what is your logic? You tell me. What is the number of device complexity?
36.
36. Okay. So now tell me, if you want to say device complexity, how you justify that for layer arrangement?
Like the way of stacking the device layers will depend on, like, complexity will depend on how the layers are stacked on each other.
Correct. So that you are applying to overall device?
Yes, sir.
Okay. Because you are thinking that if that changes, overall device behavior change. Am I right?
Yes, sir.
Yeah. Then you can apply. Very good. So number is, I think, I don't know. What is that?
36.
Device complexity 36. Yeah. That also can be. But I considered only shape. Okay. So please write there. Shape as well as device complexity. Both. You can assign to layer arrangement. That's a good point. Next, thickness. Thickness. That is very easy. Come on, come on. We don't have time. At least we'll complete the generalizations. Thickness directly you can assign to
Area of stationary object.
a thickness area. How it becomes?
Sir, the
Is this
surface.
thickness is one dimension or two dimension?
One dimensional.
One dimension means related to one dimension. What is there in 39 parameters? You see, direct one. Even hint is not needed.
Weight.
Huh?
Weight of the object.
See how length is there, na? Length of length of the stationary object. What is the number?
4.
4. So length of the stationary object, it's a one dimension. Am I right? Thickness is also one dimension. Overall thickness I am telling. Layer, complete layer thickness. So you can give that length of the stationary object because layer is not moving. Next.
The amount of substance we can't give.
No, amount of substance again, what is the dimension? Amount of substance is defined as mass. So mass is dimensionless or weight.
Okay.
Okay. That's what you have to look at the dimension. See, always thickness is one dimension. I will immediately ask what are the units. You will say meters or centimeters or micrometers.
Okay.
That is the length. Okay. Next. So packing density already we discussed. What is the generalized parameter for packing density?
Strength.
Shape and volume.
Yeah. Shape and
Strength.
volume. Strength.
Oh, sorry. Yeah.
Yeah, strength you can take. What number somebody can tell?
14.
14. Yeah. Okay. Now voltage or power generated already we discussed. Voltage we discussed as potential difference. So that is also come under force. Because we are measuring only voltage. And external pressure and external temperature directly you apply to pressure to force, temperature to temperature. These are all there. So in this device case, those are not significant. That's why I'm not considering them. Okay. So now generalizations are over and noted down. Hopefully, at least some people noted down that. And I'm happy that you came up with something different parameters than what I thought, especially in the case of force supplied or frequency, you correlated also to energy. And somebody correlated layer arrangement to device complexity. Those two things, I didn't think in that direction. That's very good. Okay, so these are the different parameters I consider. Okay, I consider. So now generalizations are over. So power is anyway, directly power is there. I don't know the number. So what is the number for power?
21.
21. Yeah. So 21 is the power number, strength. So length, shape, because here you considered energy also. Sorry, here you considered device complexity also. So you have to separately work out that. That conflicts you have to separately work out. Now, I will tell you, in this device, what is the ultimate target? What is the ultimate target? With the minimum force, we need to generate maximum potential. That's what. Okay. Even they are understanding in robotics, the future, the triboelectric skin is going to be based on this effect only. So here, if you apply the little force also, that means you have the touch sense, right? The touch sense kind of thing. The touch sense, if you have less force also, if this potential is spiking high, then that is a good device. That's a very sensitive device. So that is what we are actually targeting. So what should be our improving parameter in all cases? What should be our improving parameter in all cases?
Potential.
Potential difference. This one. So, sorry. This one. Potential difference should be improving parameters in all cases. Now, keeping the potential difference as improving parameter, now you test all other parameters as worsening parameters. Okay. Now you have to go to the matrix called Altsheler contradiction matrix. Okay. That is the next step. In Altsheler contradiction matrix, there are two, one column and one row. That is, the column indicates improving feature. What is your improving feature in all cases? Improving feature should be for potential difference. So all others can be taken as the worsening features or worsening parameters. Okay. So tomorrow, please come or keep ready the Altsheler contradiction matrix. You download, take printout or keep it ready. Okay. So if you have a contradiction matrix, immediately we'll start working out like this. So potential difference means we assigned it as force. So what is the first one? Stability of the object composition. This one. So this one is the worsening parameter. Force is the improving parameter, that is potential. Stability of the object composition is the worsening parameter. So this we have to work out. So what is the force number and what is the stability of the object composition number? Can somebody tell?
Force is 10.
Force
And
is 10. Hey, force
and
10 or?
Force is 10.
Okay.
And stability is 13.
Stability is 13. So which cell you have to see in the contradiction matrix? 10, but wherever force is there, that you identify on the y-axis, that is improving feature is the force and worsening feature is at stability. So where is stability? Anybody having this one? Contradiction matrix. So you just look at the stability. So if you look at, you will get 4 numbers there. So what are those numbers? Can somebody tell?
35, 10 and 21.
35, 10, 24 and 21. Am I right? 3 numbers or 4 numbers?
3 numbers.
No, 4 numbers. That's why please download the correct contradiction matrix. Then keep it ready. 35, 10, 24 and 21. Okay. So those are the principles. So we call them as inventive principles. Okay. So that we will discuss tomorrow. Please come tomorrow because you can see how difficult it is to work out for each contradiction. So force versus stability, force versus shape, force versus area, and force versus quality of the substance or the matter, surface charge, force versus stress, force versus duration of action by stationary object, force versus shape, force versus length. Okay, so everything we are doing. So in this, from the contradiction matrix, we find these things. Okay, so please come with the contradiction matrix printout, or you keep it open tomorrow. Then one by one we will do. If you have a printout, that would be good. Anyway, you have to use it in exam. Okay, so please come up with the contradiction matrix tomorrow. Then we will discuss the next step in TRIZ method. Okay, so once you use the contradiction matrix, for every contradiction, you are going to get 4 keywords. Those keywords are called inventive principles. Okay, so please also print out inventive principle list. Okay, inventive principle list. So tomorrow you must have contradiction matrix printout. Tomorrow you also should have inventive principle list. Okay, so those things tomorrow we will discuss. Yeah. So if you have any question, you can ask another 5 minutes. So Surya, you can stop recording.
Yeah, okay, sir.